I'm evaluating electronic door restrictors that are used in most elevator systems. But let's take a look at one that we have here. This particular restrictor system uses optics. These are the brackets for the optics. It also is supplied with hardware and a door bracket and a ramp that allows the bolt, if it happens to be in the lock position, to ride up the ramp and drop into the lock position again after the door is closed. Now, this is an interesting setup. One of the things that I noticed right away was all these parts have to be wired. So that means for every optic you mount, you have to run wire back to the control box. Let's take a look at the bolt. The bolt, again, has to be wired. They give you enough wire here, probably enough to do the job. But the interesting thing about the bolt is it's a simple solenoid. It does not hold position, which means it requires voltage to remain in the unlocked position. Also, they have a retaining clip here that keeps the plunger from leaving the solenoid housing. Now, if you look at the solenoid bolt itself, what you find is the bolt is approximately 3/8 of an inch wide, and the throw of the bolt is 5/8 of an inch. So that's what you're relying on to secure the elevator door. A 3/8 inch wide bolt with a throw of 5/8 of an inch. Let's take a look at the control box. The control box is really the heart of these restrictors. Now, the control box has a PC board in it and a transformer. Now, based on what I see on the transformer, it says that this transformer will operate with an input voltage of 120 volts AC, which means that's the voltage this unit requires to operate correctly. It can't operate on anything but 120 volts AC. The other thing I see in this box is a battery. The battery has a sign on it, and it says replace battery before 12/2013. That indicates to me that the battery has an absolute shelf life, that no matter how this unit is used, the battery has to be replaced. Now, we bought this about 3 months ago. So if that's an accurate tag, then you're getting about 15 months out of a battery before the battery is required to be replaced. Now, let's go back to the optics for a moment. One of the things we did was we tested the optics for sensitivity. And what we found was we can take a small piece of plexiglass, which we've smoked a little bit, as you can see, and we put it in front of the optics. We cause the optics to fail. We cause the optics not to see the reflective tape. Well, what that tells us is that these optics will fail in a moderately dusty, moderately smoky environment. Something you might experience if you had a fire in the building and some smoke intruded into the hatchway. You might cause these optics to fail, based on our test. If you'll notice, that's not a lot of smoke, but it was enough to fail the optics in this particular unit. Now, let's take a look at another electronic restrictor that's on the market these days. This restrictor uses a completely different bolt system. And one of the things that stood out to us right away was that this bolt system is completely wired to the control box. So there's no extra wiring to do, there's no extra wiring to run. Now let's take a look at the bolt. The bolt, first of all, looks like it's more substantial, and it is. It's a 1/2 inch bolt. The bolt is made out of stainless, and the throw of the bolt is approximately 1 inch. Now, the bolt housing, if you'll notice, is a little longer than the other unit, but the interesting thing about this bolt is when I put it into the unlocked position, if you'll notice, it stays there. This unit uses what's known as a bistable solenoid, which means it has 2 stable positions. It has the unlocked position, stable, and the locked position, stable. What does that translate to? That translates to no battery. If you'll notice inside the control box, there is no battery, which means there is no battery to maintain or replace every 15 months. Now, let's take another close look at this bolt. housing. The bolt housing has a micro switch in it which feeds back bolt position, which can be used by the controller to signal the controller that the bolt is in the locked or unlocked position. And it also has a magnetic sensor here at the bottom. The magnetic sensor is used to monitor magnets that are embedded in the locking block which rides with the door. So again, they don't use optics to feedback when the door is in the closed position. They use magnetics. Again, magnetics would need no maintenance. Now, one of the other interesting things about this system is it comes with this has a cover on it which keeps it dry and clean. It comes with a ring out of the top which unlocks the bolt manually. So if you needed to unlock the bolt manually, you don't have to take the cover off, you just pull on the ring. Now let's take a look at the control device. This particular unit has a control board, and the first thing that stands out about this control board is there's no big transformer. They use a medical power supply, and the medical power supply is rated for 100 volts AC or DC to 250 volts AC or DC input, which means this provides a whole lot more versatility when you're on an elevator car top. Not all elevator car tops have 120 volts AC. Most Otis and Westinghouse don't. Yet this will hook up to any voltage you encounter on the car top, as opposed to the previous unit which required 120 volts. Now, if you'll notice, hanging off the end of this is a box. Well, that box is an RFID reader. And this is how this unit releases at each landing. They use a target with a target tag, and when the target tag is in close proximity to the reader head, it unlocks the door. Now, unlike most optics, we tested this first of all with our plexiglass that we used to test the other one, and it unlocked fine. We actually went as far as to put a 2x4 between it and the tag, and it still unlocked fine without an issue. So what does that tell us? It tells us two things. Number one, there are no batteries to replace, no maintenance involved. Number two, if this will read through a 2x4, it'll also read through any dust or smoke that might be encountered in the hatchway. Again, relating to no maintenance once it's installed. Now, in addition to this unit, they have a secondary unit. And this secondary unit, if you'll notice, is a little bit shorter, and it doesn't have the reader mounted to the side. And the reason it doesn't is because this unit is designed to accommodate a signal from the control system, either a door zone signal or a door open signal, or whatever signal the controller can send us to unlock the door when the car is in the unlocking zone. With this unit, you don't need targets in the hatchway. It's a much quicker install. Again, like the previous unit that we looked at that required the RFID targets and RFID reader, this unit doesn't have a battery, has a pre-wired bolt, and it has the same bolt arrangement as the previous unit. Now, one of the other things both of these units have that the previous unit that used optics didn't have is it has a release button on the side, so that if the mechanic is on the car top and needs to release the door for some reason, he can simply press the button. If he doesn't have power, he can simply pull the ring, and the ring will release the door. And that pretty much concludes our comparison of electronic door restrictors: optic style, RFID style, and direct connection to the control style.